Right, welcome back, scholars. We're gonna kind of wrap things up today around our fractions for now, talking about the differences of fractions. This is an opportunity, again, if you have not watched addition or sums of fractions, I would like you to go do that now, because we're gonna skip a lot of steps because those steps are the same, but you learn through sums, and then we're just gonna apply the differences today. So go ahead and pause this and take off and go watch the other video if you haven't yet. If you've watched those, then here we go. Let's dive into this idea of differences of fractions today. Remember, vocabulary differences is really just referring to subtraction. So we're going to be looking at how do we subtract fractions from one another, and what does that mean? And we're going to do that through a step-by-step process as always. So we're going to kind of look at how we might just model the first fraction. And then we are going to then subtract the second one. So, and then that will just give us an answer. We'll write that right as a number, or right as a fraction, right as fraction, right? So these are our three steps of what we're going to do. We're going to model the first, subtract the second, and then write as a fraction. With sums of fractions, remember we modeled both to help us put them together. In this case, we only have to model one. So let's just dive into that with some examples today. Let's go ahead and start with 7/10. We're going to take 3/10 away, right? So again, if you think about those steps, step one, we just want to model our first fraction. So our first fraction here is 7/10. So I'm going to go ahead and draw a model, cut that into 10 pieces because that's what my denominator says. 1, 2, 3, 4. And then we're going to shade in 7 of them. So let's change colors for that. 1, 2, 3, 4, 5, 6, and 7. Okay, so that was our first step, right? We just went ahead and we modeled. And then what we're going to do is we're going to take the second fraction away from this model, right? That's the subtraction part. So if I look at the second fraction, we see we have 3/10. So I first started by shading 7, but now my numerator tells me I just need to take away 3 of them. So I can just do this like 1, 2, 3. I could cross them out. And then we just say, oh, well, what's left? And if we look, we have 1, 2, 3, and 4 out of 10 left. So you know, like I said, we're just trying to kind of skip out on like some of the y's because we did those in the sums video, but here we can just see that same process. So we're going to model the first, then we subtract the second, and then you just have your answer. Okay, so let's just practice a few more, of course, just to get going. Maybe here in this case, let's take 3/4, and we're going to subtract 1/4 from that. So again, step one, let's model our first fraction only. Okay, and there's 4 parts. We're going to shade in 3 of them. 2, 3. And then we're going to go ahead and go back and subtract the second fraction, which is 1/4. So we're just going to get rid of one of these that we shaded. And I now can see that I still have 4ths, but I now only have 2 parts. So 3/4 minus, minus, I said, not equals, minus 1/4 equals 2/4. So there we have it again. So if we really think about this process like modeling, and this is what we talked about in the sums of fractions, is that we notice that there is a trend that we don't always have to model. We can also look at our subtraction of fractions with the concept that if my denominators are the same, right, which they are in this case, then I'm keeping that denominator because that obviously never changes, right? It's not going to change how many pieces we have. And then I just do the mathematical process of 6 minus 3 with my numerators, and I get 3/8. So we can also just use this algorithm. We can use this math concept just to get there. If the denominators are the same, just slide it over and then subtract your numerators, 6 minus 3. And we can put that to theory, right? That's always the case. Here's how we can do it mathematically. Well, let's prove that with a model of some sort, right? Let's prove that out. So let's follow those steps. We're gonna model the first fraction, right, which is 6/8. Okay, so let's see, 1, 2, 3, 4, 5, and 6. And then let's subtract 3 of those, right? That's what the other one says. So I'm just gonna, let's see, oops, sorry. Let's just do 1, 2, 3. There we go, that's what I was looking for. So we just went ahead and erased those, and that leaves us with 3 out of 8, and that's what we see here, right? So again, we have this modeling system that can be very helpful, and then we also just have this algorithm. So let's just do another one. What if I had like 9/12 minus 4/12, right? Well, again, denominator is the same. So we're going to slide that one over, right? We're just going to keep 12. And now let's just subtract 9 minus 4. Well, that equals 5. And why this algorithm works really well is if we think about, like, what if we were given an example of like 37 hundredths minus 12 hundredths, right? And again, this only works when our denominators are the same, which they are. So we're going to call that 100, slide it over. And now we can just do that subtraction of 37 minus 12 instead of thinking about, oh my gosh, could you imagine if I had to take a model and cut it into 100 pieces, right? And then sit there and shade in 37 of them and then erase 12, right? This is where like the algorithm is so helpful in understanding. And again, I want to keep reiterating, meaning I'm going to keep repeating that this works when our denominators are the same, which is going to be the case for most of the problems we do for now. Okay, so there you have it. So let's go ahead and just do one last one and wrap this up. I think this is definitely clicking. Someone came along and said, oh, I have 29/35, and I need you to take 6/35 from that, right? Because, you know, that's what people do. They walk down the street and just ask you to do random math problems. Well, our denominator is the same. So it's still going to be out of 35. It stays. That never changes. And then let's do the algorithm of 29 minus 6, right? We're just going to subtract our numerators, or the parts that we have, or that we're taking away, however you want to view that. Looks like we get a 23. And there we go. Okay, so thinking about that with the differences of fractions, that should come in very handy. We'll post another one of what happens if I have to start subtracting when my denominators are not the same. What do we do? We'll post another video on that shortly, but for problems where the denominators are the same, as you can see, this is how we can subtract them. As always, thanks for watching. Thanks for being here. Thanks for working hard, and we'll see you next time.